black holes have been considered space's most mysterious and difficult to grasp wonders. These gravitational beasts are known for devouring anything that comes closer to their event horizons. They are the leftovers of huge stars that imploded within their gravity. Astronomers and researchers have been baffled by their ravenous hunger and inscrutable behavior for many years. However, thanks to the work of famous physicist Michio Kaku and his novel hypotheses, we are now nearer than ever to deciphering these cosmic marvels' secrets. Here in this video, we'll talk about what recently has been found about black holes. The gravitational waves created by two black holes. One of the biggest questions about the cosmos is whether black holes exist. Their compactness and density make them gravitationally extremely powerful, making escape nearly impossible. It is difficult to determine the exact number of these starving objects, but the Milky Way is estimated to contain over 100 million black holes. To better understand the structure of the black hole universe, specialists like Michio Kaku have calculated the volume of this enormous structure, which is almost 4 million over the dimensions of the Sun. Scientists reported seeing gravitational waves from the South Pole in 2014, but later retracted their claims after realizing the signals had been produced by interstellar dust. Two black holes, each possessing a mass 30 times that of the Sun, were detected by telescopes set up to look for gravitational waves. They are located trillions of light years away from us. Decades have been spent searching for these waves, but now scientists have a fresh, oral perspective through which they may examine the universe as a whole. Albert Einstein first proposed the possible existence of gravitational waves in 1915, but since then, scientists have only been able to infer their presence. Einstein projected that we could never observe gravitational waves because they traverse through time and space at the speed of light. Identifying gravitational waves has the potential to have broad implications for our knowledge of the cosmos. One of the world's leading theoretical physicists, Michio Kaku, has predicted that whoever works on this subject will soon be awarded the Nobel Prize in Physics. Gravitational waves and the birth of the cosmos. Michio Kaku claims that the discovery that electromagnetic radiation could be utilized to convey information about galaxies kicked off the second phase and ultimately contributed to discovering objects in space as quasars, known as black holes. Galileo's research on light waves provided conclusive evidence that the Earth revolved around the Sun. This discovery shook the basis of the Catholic Church and its concentration on geocentrism and ushered in the era of the initial wave of enlightenment. Gravity wave sensors have been proposed as a possibility for the third wave by Michio Kaku. Planets and stars were found first, then galaxies, and lastly, the finding of galaxy mergers and the Big Bang will arrive in a third wave of cosmic exploration. The Big Bang may be a major source of gravity waves. The discovery of gravitational waves could pave the way to understanding the conditions that led to the Big Bang that launched the cosmos into existence. Although this is merely an idea, it stands to reason that if gravity monitors were installed in Earth's orbit and the event's emissions came to light, additional details could be gathered about the occurrences leading up to the Big Bang. Kaku formulated this theory by investigating the origins of the Big Bang. Many theories are floating about, but they will be tested once gravity wave detectors in orbit are up and running. The start of a brand new era. Some believe our relatively young universe was born with an umbilical cord still tied to an older cosmos. Many wild predictions made in notorious fantasy movies may become actuality as scientists learn more about gravitational waves. In science fiction, black holes are frequently featured due to their destructive power. Space is a cloth, thus it's feasible for waves to travel through it. Given our newfound understanding that clothing may tear just like any other material, we might reasonably wonder what happens when a black hole tears the material out of space and time. Given how little we now understand black holes, an empirical response to this topic is out of the question. With our new ultra-sensitive telescope, we can witness the moment when two black holes collide. This may herald an exciting new phase in the never-ending debate over what happens to a person when they fall into a black hole. Many people have different ideas about what happens if you fall into a black hole, such as the idea that you'll never be seen again. Some people think you only pass through, while others claim you let knowledge escape. Some people mistakenly believe that because the cosmos rotates swiftly, has a ring shape, and enters its center like falling into a mirror, it is in fact a black hole. Progress in understanding black holes. Dr. Michio Kaku and his team have uncovered some interesting new directions to explore, but further research and observational proof are required to corroborate their forecasts. Advances in astronomical instruments have enabled us to explore the composition and behavior of black holes, as evidenced by the historical results of the Event Horizon Telescope, which provided us with the first image of the space immediately surrounding a black hole. Further studies and investigations will be very helpful in learning about black holes. As it approaches the event horizon, the mobility of matter can be seen by the detection of gravity waves, which could supply researchers with essential data to evaluate and upgrade present hypotheses. Lastly, don't just be a viewer, be part of our YouTube family. Subscribe to our channel and join the conversation. We value your feedback and look forward to hearing from you.